Steady-state thermal conductivity testing is often treated like it's one single category, but in reality, the methods within steady-state testing are designed for very different purposes. Two of the most common steady-state techniques are the guarded hot plate, or GHP, and the heat flow meter, HFM. And even though they're often compared side by side, they're frequently misunderstood. And when you compare these methods without considering what they're intended to do, it can lead to the wrong expectations around accuracy, test time, or even whether the results are truly fit for the application. So today, we'll break down the key differences between guarded hot plate and heat flow meter, and how you choose the right method for your testing goals. At the core, steady-state thermal conductivity testing measures how heat flows through a material once the thermal equilibrium has been reached. A controlled temperature gradient is applied across a sample, and thermal conductivity is calculated from the resulting heat transfer. Both GHP and HFM are based on the same steady-state principle, which is why they're widely used in industry, research, and standards-based testing. But even though they share the same foundation, they differ in a big way. Guarded hot plate measures heat flow directly, while heat flow meter measures heat flow indirectly using calibrated sensors. That difference shapes everything from accuracy and traceability to speed and ease of operation. Let's look at what this means in practice. Guarded hot plate is designed as a primary measurement technique with a guarded configuration that minimizes edge losses and tightly controls boundary conditions. Because of this, it's known for high accuracy and strong traceability, especially when measurement uncertainty needs to be carefully controlled. But there's a trade-off. GHP testing typically requires longer test times, larger, carefully prepared samples, and more complex system operation. So while it offers excellent accuracy, it's often a slower and more resource-intensive approach. Heat flow meter systems take a different approach. Instead of measuring heat flow directly, they use a calibrated heat flux sensor to determine the heat transfer through the sample. Because HFM is optimized for practical testing, it often provides faster measurements, simpler sample preparation, and higher sample throughput. While it typically doesn't reach the same level of absolute accuracy as guarded hot plate, HFM offers excellent repeatability, which makes it ideal for routine testing and quality control. So how do you decide between the two? The answer depends on what you need for your data to accomplish. Guarded hot plate is best suited when you require maximum accuracy, strong traceability, or compliance with primary measurement standards. That includes use cases like reference testing, material certification, inter-laboratory comparisons, and applications where uncertainty must be closely controlled. Heat flow meter is usually the better choice when your priority is fast turnaround, consistent repeatability results, and high sample throughput. It's widely used in manufacturing environments, applied research, and quality control settings where efficiency matters. Ultimately, selecting the right method depends on your testing objectives, throughput needs, and any standards you're working under. And if you're unsure, Thermtest Method Match Approach helps align your material, application, and performance requirements with the most appropriate testing techniques. Here's the key takeaway. Guarded hot plate and heat flow meter are complementary steady-state methods, not interchangeable ones. Each plays a distinct role within the thermal conductivity testing, and choosing the right method ensures your data is reliable, relevant, and fit for purpose. By understanding the strengths and limitations of each approach, you can generate thermal data that supports confident engineering decisions, meaningful comparisons, and long-term data integrity.